Hi everyone, welcome to today's session. We've covered a lot and the way you can fully benefit from our videos. As I always said, start watching it from the oldest to the most recent. And that's why we have different playlists. Okay, so you go to those playlists. And again, know that this or the courses or playlist has been carefully created by myself. So make sure you start watching it from the from the oldest to the most recent. And you guys realize that we started off with basic, introducing networking, and now we are taking it one step at a time. That being said, I will share my screen, and today we'll talk more on switches, right? Remember, we started off by defining what a switch was. We said a switch is allow communication within a local area network, while it will route traffic to the recipient, the intended recipient. And each time we make that statement, we also say that it definitely use the MAC address. So we pause, we have to understand MAC addresses. From there, we have to also discuss NIC, that's a network interface card. But let's try to understand the functionality of a switch. What does a switch do, right? It says that when a device sends data, the switch checks the MAC address. I believe as of now, we already know what the MAC address is, where we say that it's a unique identifier for your device. In that each and every device do have a MAC address, the sender as well as the recipient, which then forward the data only to the intended recipient device within the network. Say, for example, if you send an email from your laptop, the switch will send the email only to the laptop's recipient, not all devices connected to it. And remember, we compare a switch to a postal guard who delivers people emails or messages, right? And mails rather. So because that person really have the different addresses, it definitely knows who to route or send or deliver our their mails. So just like a postal guard, a switch also understand and know the devices that are connected to it. And think we also talk about MAC address table, and that's how it's able to route those traffic. And if you look here, we have a few examples, some of the network devices that we spoke on our previous videos. Because they are connected to this switch, do you see the switch already knows which device to route that information to? Then we'll also briefly talk about hub. So there's a switch and there's a hub. Yeah, people do also use hub. A hub also has its own functionalities. So unlike a switch, a hub doesn't know how to keep secret. Do you see when we go to a switch, the switch will see who that information is meant to, and the switch will route that information to that recipient. But the hub doesn't know that. The hub is not a semantic device. So what the hub do is that the hub will broadcast the information to all devices connected, right? And that's why I say the hub which broadcasts data to all devices on the network. Switches are more efficient. So they always send data to the device that needs it, reducing network traffic. And the hubs is compared to like the MC in a party or any occasion. When it's time for the MC to talk, everybody will listen. Hello, guy, ladies and gents, welcome the bride or wherever. Everyone will have to listen. So at that point, you're broadcasting that information. It goes to anyone in the auditorium or the facility or hall. Unlike if I have my bestie in that hall where we want to, of course, bestie would talk. If I have to talk to my bestie, I want to whisper in her ears, like, oh, this, that. So that is a switch because it's efficient. I just want my bestie to listen to what I'm about to tell her, not broadcasting it to everyone in the party. Okay. And this definitely explain the difference between switches and hubs. If you look here, we have all the different devices connected to that switch. And you'll see if that data is meant to be sent to this device, the switch is going to send. But you do see that the hubs doesn't know that. The hubs is going to broadcast it to everyone. And likewise, same picture we also have on the right-hand side. Do you see the hub doesn't know that? You see the data they help literally broadcast it to everyone, and that that every device is connected to the hub. But unlike the switch, this particular device wants to communicate with this one. Once it gets to the switch will be able to identify and know the recipient, and that's how the switch will route it to that recipient back do you see it will not send it to this other recipient. But in the course of doing that, how would a switch be able to understand or know the um the intended recipient? And that's what we call the switching table or MAC address table. So what happened is that the switch maintained a MAC address table to remember the addresses of devices connected to each port. This allows a switch to send data directly to the right device without needing the broadcast. So with the help of that MAC address table, remember I already said that MAC addresses are unique identifiers, right? So each and every device do have a MAC address. And if they have a table that the switch already have all those MAC addresses, that's how the switch is able to tell who and when to send that particular information. But what happened if a new device is being added? And that's why it says that when a new device is connected, the switch adds its MAC address to the table and knows where to send further data for that device. Because a new device, a new employee that got added, they have to add their information and everything. That device or your laptop do have their MAC address, right? And that's why the switch will have to update, that table is being updated. That way, as a new employee, we have to welcome that employee. He or she needs to start their job. So the switch will definitely have their information on that MAC address. And guess what? For any future communication. And this gives us a good pictorial view as to or visualization as to how this plays in real life. Do you see? We have different devices, and if you look at the MAC address cable, those are the MAC address port 1, port 2, port 3. Or likewise, you have port 1, 2, 4, so you ready or port 1, 2, and 4. Do you see? So we have the MAC addresses. So the switch already have the MAC address table or the switching table such that if I want to send a message to you, the switch already knows, because the switch have your MAC address, like that postal guy that have or knows people addresses, they'll be able to deliver the information directly to the person. But talking about that, let's briefly talk about the different types of switches, right? So the first one, we have an unmanaged switches, which these are just simple switches used in your home networks where no configuration is optional. Nowadays, you just plug, I don't know, we go with optic fiber. Nobody needs to do it for you. Initially, I used to call, they'll come do it. I'll just pick my item, put it, plug it. If there's anything that you need to troubleshoot, you just call their customer service and they should be able to help you, right? So we also have managed switches. This is used in business environment that allows network configuration monitoring as well as troubleshooting, especially at the level of the enterprise. And then we have power over internet service. Internet, you guys, as of now, we're talking about the physical connection, and it was important for us to cover that because imagine introducing a term like this, of which we do not have the background. So if you are currently watching this video, make sure you start from the previous if you really want to fully benefit and understand these concepts better, right? So provide power and data over a single interconnect cable to that's connected devices like your IP cameras or phones, right? And the next picture definitely explain or what we cover. For example, we have the unmanaged switch. We have managed switch in an enterprise DOC business, and then we have port over internet where it may be connected to your cameras or whatever device that might be, right? But let's learn some of the functionalities of switches. It's really, really important, okay? So the first one we talk about learning. First, it says a switch learn the MAC addresses of devices on the network as they receive data. So the course of doing that, remember we said that the switch will definitely have to learn, have those MAC addresses, and then know that, hey, you know what, I'm going to send the information to this particular device. Then once the switch has identified or learned the MAC addresses, the next function is to be able to forward. It said once the switch knows the MAC address, it then forwards data directly to the right device as we have discussed. But another interesting function has to do with flooding. And I know you will ask me, but if the switch, do you see, if the switch doesn't know the destination MAC address, it will flood the network with the data and wait for a response. Someone was asking me, so if the switch will have to flood this data to all the devices, then what is the difference between a switch and a hub? Because the hub also broadcasts the data, right? For example, let's go through the first one. You see, it has to learn, it's learning the MAC address for each devices. That it must have learned that it forward it to the rightful or to the right recipient, so it forward that data. But do you see the catch here? If it doesn't know the MAC address, then it floats that data to all the devices connected to the port, connected to that particular switch. And we also said that the hub will broadcast. The hub doesn't know how to keep secret. The hub is like that MC. But do you know the catch? That says that the switch will do that and wait for a response. So the difference here again is that the switch does not or will not deliver the data or the information. It has to wait for a response. But the hub doesn't wait for a response. The hub delivers, right? The hub delivers and it goes straight, but the switch doesn't wait for a response. So this is the key difference. So waiting on a response, what does it mean? And that's where we will touch an important concept. We talk of three-hand we shake, TCP three-hand we shake. I believed even when you are visiting the internet, this definitely happened. When remember we spoke on NAT, network address transmission, when you are going through the network, it converts your private, IP, if you have to go through the internet, that's something that we're going to discuss. Each time you're visiting a website, things of connection don't just happen like that. And, it has to go through a three-way handshake. And that's something that, as I said, we will discuss. So likewise, the switch again at this point is still very, very efficient because the switch will have to wait. When the switch send the information, guess what? The because it doesn't know the laptop, it doesn't know the MAC address, and then that laptop, that's if there's a match, because again, once it send it, it will wait for a response. Of course, not all of them will respond. Maybe this was replying what, oh yeah, it is me, oh it is me, and then the switch will have to verify if that MAC address, if that device actually, if that message is meant for that device, then the switch will definitely update the MAC address table. Tell me, are you guys not enjoying this course? It's very, very interesting, guys. I cannot lie, right? Then we'll also talk about the methodologies, switching methods. First one has to do with store and forward, which says that the switch receives the entire data package, check it for errors, and then forwards it, which makes sense. It checks it if there's any error before it could then send it or forward it. Then we have two, cut through. The switch begins forwarding the data as soon as it reaches the destination address, right? Making it faster, but with fewer errors. So again, as soon as it receives, it definitely forward it. It is faster, but also have a disadvantage, fewer errors. And the last one, talk about fragment free, which says that this is a hybrid approach where it first of all check for the first 64 bytes. And this data package, they come in bytes, check for the first 54 bytes of the packet before it could forward it to the recipient. And this picture definitely covers everything. So with the very first one, store and forward, it first of all receive a check if there are any error, before it can then forward it. Likewise, cut through is sent it for faster delivery, but with fewer errors. And then this one, as soon as it read the first, remember all this thing again, with the MAC address, as soon as it read the first 64 byte, it already know who and where to send that particular information to. And this brings us to the end of switches, but we're still going to talk switch. I'm going to split the video. We're going to talk about VLANs, that's virtual local area networks. Remember, at this point, we've talked about LAN. I don't know if we briefly touched on VLANs, but we're going to talk about VLAN and switches and see how they work. And this should be another video. So guys, make sure you comment, make sure you subscribe, make sure you put that thumb up, make sure you share with your friends and loved ones. And I will see you all in the next video.